Good morning. My name is Adrian Arcon. I am electrical engineer and I work at CIRCE like technical research. CIRCE is a technology center that offers new solutions for a sustainability future. We have a team of highly qualified experts from different fields. Our goal is to help companies be more competitive, be sharing new technology. We do this through research, develop, innovation, and market-oriented training. We focus on sustainability, resource, efficiency, energy networks, and renewable energy. We work for a more sustainability and efficient future. CIRCE mission is to help companies be more competitive, be create and sharing new technology. We do this through research, develop, innovation, and training. Our focus is on sustainability, resource, efficiency, energy networks, and renewable energy. CIRCE is leading Task 3.2 energy planning tools considering grid aspect in collaboration with prominent partners shown on the slides. This task unfold over a period of 28 months from month 3 to month 31. The task 3.2 is divided into two subtasks. Task 3.2.1 focusing on developing and hosting capacity analysis tools, and task 3.2.2 dedicated to create the optimal storage placement tools. Let's zoom into task 3.2.1, where focus is on developing and hosting capacity analysis tools. The key activity can be summarized as follows. First, we will analyze open source resources like the Python programming language and tools such as GridCal used for power system analysis. Second, we will develop the hosting capacity analysis tools for electrical system planning, analyzing the integration of new generation capacities and loads. Finally, we will include functionalities for contingency analysis, integrating indicator or KPIs to find optimal resource in economic and environmental aspect. Hosting capacity methodology. This slide describes the methodology associated with developing the hosting capacity analysis tool. First, we will analyze local electricity system regulation and regulatory requirement. Second, we will gather available models and database that describe the local electricity system. Third, we will analyze available open source solutions for developing the hosting capacity tools. Four, we will develop the hosting capacity tool to analyze the integration of new generation elements and loads. Finally, we will implement functionality for visualizing key indicator and KPIs. The program or code creates sets, busbar line, and transformer. This slide is the algorithm explanation of hosting capacity tools. The algorithm or the program creates set of busbar lines and transformers. The program checks for overload in the sets. This is the initial overload and save overloads in database. The program iterates over the busbar set. For each busbar, the program creates a generator. This generator increases generation from 0 In this create step, for each increment in the generation, evaluate overload in lines and transformer of the models. If there's overload, compare with pre-existing overload saved in database. Save the new overload data in a database if new. Repeat step 3 and step 4 for all scenarios. Create report table, display generation values without overload in each bus bar. This is the end of algorithm.